Hello learner, welcome to the another lecture on electric propulsion system and constituent technology. In the previous lecture, we have discussed about electric propulsion system and its two major component, that is energy source and storage system and electric motor. In this lecture, we will discuss about the third major component of electric propulsion system, which is power electronics converter. So, let us delve into the role and responsibility of power electronics converter in electric propulsion system. As I mentioned that the electric propulsion system is a backbone of vehicular electrification. In that sense, the power electronics converter act as a heart of electric propulsion system, as it takes electrical power from onboard energy source and storage system and distributes that electric power to the traction motor and varieties of onboard electrical and electronics load, contributing to operation of the vehicle directly and indirectly. Power electronics converter are essential components in electric vehicle which manages the control, conversion and distribution of electrical power within the vehicle. They play a critical role in enabling efficient energy utilization from various sources available on board. For the sustainable operation of electric vehicle, it is crucial to have an onboard electrical power processing system that is highly reliable, flexible and fault tolerant to meet the vehicle's demanding power requirements. Currently, this responsibility is managed by power converters, which includes a DC to DC converter, DC to AC converters and AC to DC converter. The power electronics, again we know, a key technology for efficient electric power conversion and control in electric vehicle. The need for electric power in vehicular application is rapidly increasing as mechanical components are increasingly replaced by electrical and electronics component. These electrical and electronics component and load presents on the vehicle increases the luxurious feature and comfort of the vehicle. It is anticipated that the power demand in electrified vehicle could surge to 2 to 3 times higher than what the present vehicle is consuming because of this additional or because of this added luxury and comfort on the vehicle, whether it is a IC engine vehicle or electric. So, in future one can see the increased demand of electrical power on board on electric vehicle. So, to meet this growing power requirement effectively within the electric propulsion system or electric vehicle, the integration of the power electronics component with the vehicle's electrical and mechanical loads becomes essential. This integration not only enhances overall performance and fuel efficiency, but also helps in minimization of the emission as well as weight, size and volume of the vehicles. So, let us talk about the classification of power electronics converter available for electric propulsion system. So, the power electronics converter broadly classified as DC to DC converter, DC to AC converter, AC to DC converter as mentioned earlier. In addition with that, we also have AC to AC converter. However, in electric propulsion system, this DC to DC converter, DC to AC converter and AC to DC converter are mostly used. DC to DC converter are further classified as unidirectional, bidirectional, isolated, non-isolated and accordingly different topologies comes under this classification. Similarly, the DC to AC converter is classified as current source and voltage source. In a voltage source, we have 2 level and multi-level. Similarly, the AC to DC converter can be classified as a single phase, 3 phase, unidirectional, bidirectional or AC to DC converter with PFC, without PFC. So, this particular image shows a comprehensive classification of the power electronics converter which can be used for vehicular application as per need and requirement. A particular type or configuration can be opted. So, this converter, whether used individually or in combination, each serves distinct function within the system. Power converter performs critical tasks such as switching load on and off, conditioning power and modulating voltage and current to ensure compatibility between the power source, traction motors and auxiliary loads. In addition to converting electrical power from one form to another, power converter also facilitate the stepping up or stepping down of the system voltage levels, contributing to better performance of electric vehicle, which leads to higher efficiency. So, let us discuss the different electrical power system architecture available in electric vehicle and hybrid electric vehicle and identify the role and responsibility of power converter in this architecture. So, in the architecture of electric vehicle power system, a single DC voltage bus with provision of distributing different voltage level is anticipated. This architecture integrate various energy source and vehicle load with distinct voltage and current characteristics and dynamic responses through a common DC bus. These are connected via either conventional multiple single input DC to DC converter or single multiple input DC to DC converter or any other emerging converter topologies. So, this is the schematic of an electric vehicle. In this vehicle, one can clearly see the role of power electronics converter in electric vehicle. It is used for traction, it is used for supplying of auxiliary power unit, it is used for charging. This particular architecture shows the simplified architecture to identify and appreciate the role of power converters in electric vehicle. It is used to connect the IC engine through generator to a common DC bus. Different energy sources like battery, ultra capacitor, fuel cell and flywheel or maybe solar PV or any other renewable energy sources can also be integrated through DC to DC converter to a DC bus. Then a DC to AC converter is used to supply the traction motor for traction purpose. Then a DC to AC converter is used to supply power to high power hotel and ancillaries load, and then a DC to DC converter is used to supply power to low power conventional load. In this architecture, one can see the electric vehicle along with the charging station, either it is a off-board charging or it is a on-board charging. The sole objective of this particular drawing is that to identify the number of power electronics converter required for efficient operation of electrified vehicle and efficient charging operation. If it is a off-board charger, we required AC to DC converter. A DC to DC converter, combination of these two act as a charging unit, delivers power to the on-board battery through BMS. Then through BMS, a DC to DC converter gives it to the DC link, and from that the distribution starts. As I explained in previous diagram, a DC to AC converter is required for traction application, a DC to AC converter or a DC to DC converter required to supply power to various auxiliary and electronics load available on board, and again a AC to DC converter is required for home charging or for on board charging. So, one can easily see the number of power electronics converter required for overall functioning and operation of electric vehicle, whether on motion or during charging time. Another architecture of electric vehicle we can see is this. In this particular architecture, the charging infrastructure requires a sophisticated battery charger that typically consists of two key power processing stage, an AC to DC converter as mentioned earlier and a DC to DC converter. The first stage is designed to condition the grid current, ensuring a unity power factor, which is crucial for minimizing reactive power and reducing strain on the electrical grid. The second stage focuses on regulating the battery charging current to ensure optimal and safe charging. While dual stage converter offer precise control over both grid interaction and battery charging, single stage converter present a more streamlined alternative. These converters simplify the overall design by integrating both stage into one, leading to higher efficiency and fewer component, and hence significantly cost reduction. However, a trade-off exists. Single stage converter may not fully regulate the battery current waveform, potentially impacting the battery health and the performance of the electric propulsion system and the vehicle. Let's talk about the power converter configuration for electric propulsion system. In electric vehicle, the EPS operates in two key modes: battery operating mode and regenerative mode. Each mode involves different components and process to manage power flow between the battery and vehicle propulsion system. Battery operating mode focuses on delivering power from the battery to the motor, while the regenerative braking mode captures and stores energy during braking, contributing to overall vehicle efficiency and performance improvement by recapturing the significant of energy. So, this is a schematic of electric propulsion system. As we have seen the bigger picture earlier, this is a confined picture. Again, here you can see the role of different power converter in electric propulsion system and their importance in different mode, either in regenerative braking mode or in motoring mode. Let us see another power system configuration for grid to vehicle and vehicle to grid combination. The electric vehicle battery charging system function by connecting to an electrical supply to charge the battery with two primary mode of operation: grid to vehicle and vehicle to grid. Grid to vehicle mode focuses on charging the electric vehicle from the grid, while the vehicle to grid mode enables the electric vehicle to support the grid by returning power, as we have already discussed it in plug-in hybrid electric vehicle. Each require a specific technology and consideration for efficient operation. So, that is about the different architecture of power system which is being used in vehicular electrification, either for charging or for electric propulsion operation, or for vehicle to grid operation, or for grid to vehicle operation, and even for regenerative braking. Now, the next part is the function and operation of the power electronics converter. As we have earlier classified that the power electronics converter are of 4 types. So, a DC can be converted to variable AC, a AC can be converted to variable AC, again a AC can be converted to DC. The DC could be constant or variable, or a constant or variable DC can be converted to a constant and variable AC. So, this is the 4 major function performed by power electronics converter, and accordingly it has been classified into 4 types of power electronics converter. So, let's discuss the 3 major types of power electronics converter one by one, which has wide acceptance for electric propulsion system as well as for electric propulsion system and for charging application. So, the first converter that we will discuss is the DC to DC converter. A DC to DC converters are crucial for adjusting voltage level between the battery and other component within the electric vehicle. They can be categorized into several types as mentioned earlier based on their operation. The DC to DC converter is a critical component in the power electronic system, serving several essential functions that enables efficient energy management and distribution throughout the electric propulsion system or the different component of electric vehicle. So, let us have an overview of its importance and function. It helps in voltage regulation and distribution. DC to DC converter in electric vehicle are responsible for converting high voltage power from the main battery pack to lower voltage levels required by various subsystems and the auxiliary systems. These includes component like the infotainment system, lighting system, climate control system and other auxiliary electronics. The primary function is to ensure stable and efficient voltage regulation, providing consistent power supply to each component without fluctuation, and hence ensures the smooth operation. Another important feature of the DC to DC converter is a power conversion, One of the key role of a DC to DC converter is to maximize the power conversion efficiency. By efficiently stepping up or stepping down the voltage level, these converters minimize energy loss during power transfer, which is critical in extending the driving range of electric vehicle. High efficiency is vital for maintaining the vehicle's overall energy balance and optimizing the battery utilization. Another important attributes of DC to DC converter is integration with battery management system. DC to DC converter are integrated to vehicle's battery management system. They manage the power flow between the battery and the vehicle's electronics, ensuring the battery is charged and discharged correctly. This role is crucial in maintaining battery health, extending its lifespan and preventing overcharging or discharging, which could lead to battery degradation. It supports regenerative braking. In electric vehicle, regenerative braking is a key feature that recovers kinetic energy during braking and converts it into electrical energy to recharge the battery. A DC to DC converter are responsible for processing and conditioning this energy, ensuring it is at the correct voltage level for storage in the battery. This process improves energy efficiency and contributes to extending the vehicle range. Another important attribute of a DC to DC converter is the charging system adoption. A DC to DC converter play a significant role in charging system of electric vehicle, particularly in managing the conversion of AC input from charging station to the appropriate DC voltage needed to charge the vehicle's battery. They ensure that the battery is charged safely and efficiently, adapting to different charging protocol and voltage level, whether it's a slow AC charging or a fast DC charging. A DC to DC converter also provides isolation and safety. The responsibility of DC to DC converter extends to providing electrical isolation between different voltage domain within the vehicle. This isolation is crucial for protecting sensitive electronics component from high voltage spike and ensuring the overall safety of the vehicle. By preventing the voltage cross contamination, they help in safeguarding both the vehicle's electronics as well as passengers. Another important role of the DC to DC converter is the power management. A DC to DC converter are central to the power management system of an electric vehicle. They distribute power to various systems based on the demand, ensuring that the critical component receive priority in power allocation. The dynamic power distribution helps in managing the load effectively, particularly in scenario where power demand fluctuates, such as during acceleration or when the multiple systems are operating simultaneously. At that particular time, the DC to DC converter play a key role in managing these power and its efficient allocation. So, in summary, a DC to DC converter in electric vehicle are multifunctional component that play a critical role in voltage regulation, power conversion, battery management, regenerative braking and charging system integration. Their responsibility also includes ensuring electrical isolation, dynamic power management and compliance with automotive standard is one of the another crucial aspect that DC to DC converter takes care, all of which are essential for the safe, efficient and reliable operation of the electric vehicle. Now let's discuss the another type of power electronics converter, which is AC to DC converter, also known as rectifier. An AC to DC converter is a critical component in electric propulsion system for electric vehicle as well as in hybrid electric vehicle. It performs the essential task of converting alternating current from external source such as charging station or regenerative braking system into a direct current which is required by vehicle's battery and other DC powered system. It helps in conversion. A DC to DC, AC to DC converter, also known as rectifier, are crucial conversion of AC power to DC power. The AC to DC converter converts the AC power from grid or charging station into direct current that electric vehicle requires, as mentioned earlier. A AC to DC converter ensures that the vehicle's electrical system receives appropriate form of DC power necessary for efficient operation. Integration of the charging station in the context of electric vehicle charging system. AC to DC converter are vital for the charging process. They adapt the AC power supplied by the public or home charging station to DC power needed to charge the vehicle's battery. This role is particularly significant in level 1 and level 2 AC charging station, whereas the converter is integral to the onboard charger that manages the conversion process. Power quality and regulation. The AC to DC converter plays a role in maintaining the quality of power supplied to the vehicle electrical system. They ensure that the DC output is regulated and free from the fluctuation or ripple that could affect the performance or safety of the electric vehicle, electronics and other similar components. This includes providing stable voltage and current level despite variation in input AC power. Safety and protection. AC to DC converter contribute to the safety of electric vehicle by incorporating features that protect both vehicle and its occupants. This includes over voltage protection, over current protection and thermal management to prevent overheating. They also ensures proper isolation between high voltage AC input and low voltage DC output, safeguarding the vehicle's electronics and passenger on board from different electric faults. It also provides support for advanced charging technology. With the advancement of charging technology, AC to DC converter are evolving to support higher power level and fast charging rates. This includes compatibility with fast charging system that requires high power conversion rates while maintaining safety and efficiency. The converter are designed to handle varying input voltage and current level to accommodate different types of charging infrastructure. Another attributes is adoption to different power standards. AC to DC converter must be adaptable to a different regional power standards and grid specification. This includes accommodating variation in voltage and frequency across different geographic region. By providing flexibility in power conversion, AC to DC converter ensures that electric vehicle can be charged reliably and efficiently regardless of the local power standard. So, in summary or in nutshell, the AC to DC converter are essential component in electric vehicle and its charging system, performing critical functions such as converting AC to DC power, ensuring power quality and regulation, supporting efficient power conversion and control, and integrating with advanced charging technology. Their role in safety, communication and adaptation to power standards are crucial for the reliable and efficient operation of electric propulsion system as well as electric vehicle. The another most crucial type of power converter in electric vehicle are DC to AC converter, or we call it a inverter. The DC to AC converter converts the DC power from the battery or onboard energy source into AC power to drive the electric motor, air conditioning, etc. They are essential for enabling smooth motor operation and efficient energy use. DC to AC converter, a single phase or three phase, can be categorized based on their control techniques and the output waveform like two level inverter, multi level inverter or PWM inverter, square wave inverter, etc. So, there are different attributes to the DC to AC converter and some of them will be discussed here. Out of that, the one is conversion from DC power to AC power. It converts DC into AC. This conversion is essential because most electric vehicle motor, especially the common three phase AC induction motor and permanent magnet synchronous motor, requires AC power for operation. The inverter ensures that the electric motor receives appropriate AC power at a particular voltage and frequency level to drive the vehicle efficiently and smoothly. Another important is the motor control and its drive. One of the prime role of the DC to AC converter is electric vehicle is to control and drive the electric motor. The inverter adjusts the frequency and amplitude of AC power supplied to the motor, thereby controlling the vehicle's speed and torque. By modulating these parameters, the inverter enables smooth acceleration, deceleration and regenerative braking, which are critical for the overall driving experience and efficiency of the vehicle. Another important task of DC to AC converter is regenerative braking. A DC to AC converter also play a pivotal role in regenerative braking system. During braking, the electric motor acts as a generator, converting the vehicle's kinetic energy back into electrical energy. The inverter converts this generated AC power back into DC, which is quite varying in nature, which is then fed back to the battery for charging and extending the vehicle's range. This bidirectional power flow capability of the DC to AC converter is essential for maximizing the energy efficiency in electric vehicle. Another important attributes of DC to AC converter is power quality and efficiency. Ensuring higher power quality and efficiency is another critical responsibility of a DC to AC converter. The inverter must produce a clean and stable AC output with minimal harmonic and distortion, which is critical for smooth operation of electric motor and other AC powered components. High efficiency inverter reduces energy loss during the conversion process, which in turn improves the overall energy efficiency and range of electric vehicle. Another important attribute is the compatibility and adaptability. The DC to AC converter must be compatible with different motor types and power levels, allowing them to be used across various electric vehicle model and configuration. They need to be adaptable to different driving condition and requirement, such as city driving with frequent start stop condition or highway cruising with sustained high speed. The inverter ability to provide precise motor control under varying condition is essential for optimal vehicle performance. So in nutshell, a DC to DC converter are vital component in electric propulsion system and in electric vehicle, responsible for converting DC power from the battery to AC power for the electric motor, enabling motor control and drive, supporting regenerative braking, ensuring power quality and integrating with the advanced charging system as and when required. Their role in safety, thermal management, compatibility is also crucial for the efficient and reliable operation of the entire vehicle. So these are the detailed description of the different types of the power electronics converter. Let's delve into the advantage of the power electronics converter in or for electric vehicle and charging system. The power electronics, as we have discussed, plays critical role and it offers several advantages. The first one is the efficient energy conversion. It converts energy very efficiently, and as we all know, the power electronics converter, the efficiency of most of the power electronics converter in respective of the type or model is very high. Another one is a high power density. The power electronics converter are compact and lightweight, offering high power density. This is particularly important in electric vehicle application where space and weight are at premium. High power density allows for a smaller, lighter converter that can be more easily integrated into vehicle without compromising the performance or range. Another advantage is the enhanced vehicle performance. This power electronics converter enable precise control over motor speed and torque, contributing to smoother acceleration, deceleration and regenerative braking in electric vehicle. This precise control improves the driving experience, enhances vehicle performance and increases overall efficiency by optimizing power delivery to the motor. Flexibility in charging. This power electronics converter in charging station provides flexibility in supporting multiple charging level and modes such as level 1, level 2 and DC fast charging. They can handle varying input voltage and convert them to the required level for efficient battery charging, accommodating different types of electric vehicles with diverse charging requirement. Another important is important advantage of the power electronics converter that it offers is the improved power quality. It improves the safety features, and at the same time this power electronics converter are scalable and modular in nature. This power converter are mostly designed to be scalable, modular, allowing for easy upgrade and expansion. This is particularly beneficial in charging station where demand may increase over a time and the infrastructure need to scale accordingly without requiring complete overhaul. So, in that case this advantages of this scalability and modularity of the power electronics converter, so that advantage can play a major role. It also helps in cost optimization by improving energy efficiency and reducing energy loss. Power electronics converter help lower the operational cost of electric vehicle and charging station. Additionally, advancement in power electronics converter technology have led to reduced cost of power electronics component, making electric vehicle and their infrastructure more economically and viable and affordable for people at large. It also enables the bidirectional power flow. One of the most important advantage of power electronics converter is integration with the renewable energy sources. Power electronics converter in charging stations can be integrated with renewable energy sources such as solar or wind power. They manage the variable nature of the renewable energy, converting and conditioning the power to ensure consistent and reliable charging for electric vehicle, and hence promoting the sustainability energy use. So, these are some of the advantages that power electronics converter offers. Let us discuss some of the issues and challenges associated with the power electronics converter for electric vehicles. So, while power electronics converter are crucial for operation of electric vehicle and charging infrastructure, they also present several issues and challenges that need to be addressed to optimize their performance, reliability and cost effectiveness. So, one of the most important challenges is thermal management. This power electronics converter generates significant heat during operation, particularly in high power application, and it need proper dissipation. Inadequate thermal management can lead to overheating, reduced efficiency and potential failure of power electronics component. Another challenge is the efficiency versus size trade-off. Higher efficiency often requires larger component or more complex design, which can increase the size and weight of the converter. For electric vehicle where space and weight are critical, achieving a balance between efficiency and compactness is challenging. Another important issue is the reliability and longevity. Power electronics converter must operate reliably over the lifespan of the vehicle or charging station, often in harsh environment like extreme temperature and vibration. Component such as capacitor and semiconductor devices may degrade over time, leading to reduced performance or failure. Another important issue associated with the power converter is the cost constraint. The cost of power converter is significant factor in the overall cost of electric vehicle and charging station. A high performance power converter is especially those using advanced material like silicon carbide or gallium nitride can be expensive, impacting the affordability of electric vehicles. Another important issue is the electromagnetic compatibility EMI or EMC issue. Ensuring that the power electronic converter do not cause or suffer from electromagnetic interference is crucial for the reliable operation of all the vehicle system. Inadequate EMC design can lead to malfunction in the vehicle electronic system, including safety critical component, which may lead to the failure of several electronics component which is controlling the multiple component of the vehicle on board. Another important challenge is the safety consideration. Power converter must ensure the safety of both the vehicle and its user, particularly in high voltage and high power applications. So, these are certain issues and challenges associated with the power electronics converter. One of the another issue associated with the power electronics converter is the complex control strategy. Modern power converter requires sophisticated control algorithm to manage power flow, efficiency and safety. Developing and implementing these control strategy can be complex, requiring significant computational resources and expertise. So these are certain issues and challenges associated with the power electronics converter and inverter. So in this lecture we have seen the role and importance of the power electronics converter, how important it is to have a power electronics converter, and how and what specific role the power electronics converter is playing for the advancement of and for the sustainability of the electric vehicle we have seen, along with the types of the power electronics converter, their role and their function, along with the advantages of the power electronics converter, followed by the issues and challenges. I hope the learner have received the good understanding and overview of the power electronics converter being used in electric propulsion system. Thank you so much.